Hi everyone. Today we're going to talk about Vectric Aspire. Vectric Aspire is a powerful and intuitive software designed for CNC routing and machining. It's widely used by hobbyists, makers, and professionals for creating 2D, 3D models and toolpaths for CNC machines. Whether you're working on an intricate carving, furniture, or prototypes, Aspire provides all the tools you need to turn your creative ideas into reality. With its user-friendly interface and advanced design capabilities, Vectric Aspire allows you to seamlessly combine 2D vectors with 3D components, making it ideal for woodworking, engraving, and detailed CNC projects. In this video, I'll guide you through its features and show you how to get the most out of this amazing software. After we start the program, we're greeted with its friendly user interface, where our first step is to add and define the workpiece. In the top left field, we can notice the section Startup Tasks, where we need to click on the option Create a new file. After clicking it, the software opens up a new window named Job Setup. And here we have 5 different sections named Job Type, Job Size, Z0 Position, XY Datum Position, and Modeling. The first section, Job Type, has 3 options, and they are single-sided, double-sided, and rotary. The single-sided option is ideal for projects where you only work on one side of the material, such as simple carvings, engravings, or signs. The design and toolpaths are applied to the top face of the material, so the surface of the material. The double-sided option is for more complex projects. This allows you to machine both sides of the material, and it's perfect for creating detailed 3D designs or projects where you need precision alignment from both sides. And the rotary option is used for cylindrical or rotary machining. This option is only available if you have a rotary axis for your machine. For our application, we're going to use the single-sided options. We select it. In our case, it's already selected. And we move on to the next field, which is job size. In this section, we set up the dimensions of our workpiece. We measure and input its width, its height, and its thickness. We will work with the metric system in millimeters. Our next step is choosing a surface on which we will set up our Z origin point. The Z0 position determines where the machine will consider the starting point for the Z axis during machining. Our 2 options are the material surface and the machine bed. The material surface sets the Z0 point on the top of the surface of the material. This is the most common option for projects where we want the cutting depth to be referred directly from the surface of the material. This method is straightforward and ideal for carving and engraving tasks. And the machine bed option sets the Z0 position at the base of the material. It aligns it with the machine's bed, and it's useful for projects where accuracy in material thickness is critical, such as when cutting through the entire piece. Choosing the correct Z0 position ensures the precise cutting depths and avoiding errors during machining. For our purposes, we're going to use the material surface option. Our next option is the XY datum position, and this defines the origin point for the X and Y axis on our material. Essentially, it's acting as a home position for the CNC machine from where the CNC machine can start. The software provides several options, but most common are the bottom left corner, which we will use in our case. It's the most default and most commonly used datum position. It sets the starting point on the bottom left corner of our material, making it intuitive for many projects and easier to align with our workpiece. And you can also choose to start with the center, which sets the starting point at the center of our material. We need to be very careful when selecting this position, and by carefully selecting the XY datum, we ensure that our design aligns correctly with the material and that the machine starts exactly where we expect it to. In our case, we will select the bottom left corner as origin point for the X and Y axes. The origin point in CNC machining and design software refers to the starting reference point where the X, Y, and Z axis intersect. It's the location where all the coordinates from our design are measured from. Essentially, it acts as a zero position for the machine. Always ensure that the origin point in the software matches the origin point we physically set on the workpiece. This prevents misalignments and cuts outside of the material. The next section is the modeling resolution, and this determines the quality of the graphical representation of our models, and this option only affects the quality of the model interface. We will leave it as it is on standard settings. After we're finished with setting up the workpiece, we can click on the OK button and we're greeted with Aspire's main interface. Here it is. So here we can see on the top, on the left side of the interface, we have the main sections containing the most frequently used tools and functions. Our first section is the file operations sections, where we have multiple common functions such as new file, open file, import, save, and so on. Here we can import, save, and load files and vectors. Our next section is the create vectors, which contains all the basic drawing tools, and with these tools we can draw any shape or add text. The next section is called transform objects, and here we have all the necessary tools for modifying the drawing size, its position, its orientation, and much more. The next section is edit objects, and here we have tools for modifying, combining, and subtracting sections of our vectors and shapes. And the final section, offset and layout, contains the functions for offsetting vectors as well as creating array or patterns. We're going to use all these tools to create complete drawing, after which we will finish things up with assigning toolpaths and toolpath operations. So let's start our project by adding some text. We can do this with the function called draw text, which can be found in the create vectors section. We click on the draw text button and we're greeted with a new window, also named create text, in which we have some additional options for our letters. We can choose our font. We have a database of all the fonts which are installed on your machine. We have options to bold it and italic. Also, we have text alignment options, which determines where the text starts from the left, the right, or the center position. We can also choose the text height. This determines the height of each letter, and we can determine the position of our text by changing the values for the coordinates for x-axis and y-axis. I'm just going to input some text right now, and after we're done, we can click on the close button. Now we can see that the software has generated our text, but I'm not satisfied with its size or its position. So I'm going to change that by using some of the tools from our transform object section. But before we do that, we must tell the software which vectors we are applying these changes to. And in order to do that, we must select those vectors. So in our situation, in our case, I want to change the entire text, and I want to change its size and its position. So to do that, I need to select the entire text. When vectors are not selected, they have their classic black coloring. But after we select them, they change it to purple or violet. So after our text is selected, now the software knows for which vectors we are going to apply these changes to. And now we can choose our first option, which is move the selected objects. It clearly states the selected objects, so this is what I was referring to. This same principle is applied to all the functions, so make sure to remember that. We click on the move selected objects button and we're greeted with a new window. In here we choose an anchoring point. So our anchoring point, it's best to choose the middle one, because after you start moving the text, it will consider the middle point of it as a reference point. So we have precise movements, we can determine it by changing the values for the x-coordinate and the y-coordinates. Or we can just move it by hand by simply clicking on the middle. We first position our pointer on the middle and we wait until we get this icon. This icon, after you click and hold, it will allow you to move the text to your desired position. We will move that somewhere in the middle. This is exactly on the middle. After we're satisfied with its position, we can click the close button. We make sure that our text and vectors are selected before we apply additional changes, and we use the second option from Transform Objects, which is called Set Selected Object Size. We click on this option and we're again greeted with a new window, which is called Set Size. We also have the anchoring position from previously, and we can determine the width and the height of our vectors, in this case our text. So in the first field, we can input precise numbers, like let's say, for example, I want my text to be 85 by 12 in our case. This is automatically generated because we have selected the option Link X, Y. When this option is selected and we change one of these values, they change proportionally. So it's not just the width which is going to be changed, but also the height of the text. We can also, instead of using precise measurements, we can use it with %. After we're satisfied with our changes, we click on the Apply button and we see that our text has changed its size. However, I think that we should go a little bit smaller. So this time I'm not going to change the exact dimensions, but I'm going to change the percentage. So I'll set it up to 75%, and because this option is selected, Link X and Y coordinates, we can notice that when we change the width, the height changes automatically. So we click on the Apply button and our text changes its size once again. After we're satisfied with our text, we click on the Close button. So, next thing that we're going to do is we're going to assign toolpaths and toolpath operations. Firstly, we need to make sure that our vectors are selected. And in the upper right corner of the interface, we can see the toolpaths bar. And if we hover over it with our mouse, a pop-up menu opens up. In this menu, we have the material setup, which is the first step which we did in this tutorial. So if you need to make any changes for the material size, the material thickness, or the origin points for the workpiece, you can do them right here. Below that, we have all the toolpath operations which Vectric Aspire offers. So we're going to, for this process, we're going to use the profile toolpath. So what is a profile toolpath? A profile toolpath is a type of machining operation used to cut along the edge or outline of a design, usually to define the exterior or interior shapes of our project. It's most commonly used for cutting out parts, engraving edges, engraving letters, even trimming the perimeter of the material. The profile toolpath follows the path defined by the designer's vectors, allowing the machine to make precise cuts along the perimeter of our object. The profile toolpath follows the vector outline that we select in our design. So we're going to click on the profile toolpath. If you hover over it, it shows its name, which is named Profile Toolpath. And we have a new menu popped up. So in the newly opened window named Toolpaths, we have a couple of sections. The first one is named 2D Profile Toolpath, and it describes the operation which we're going to use for our vectors. The second section is named Cutting Depths, and in this section we set up the starting depth and the finishing depth of the drawing. So in our case it will be, well, 1.5 millimeter is perfectly fine. because my intention is to engrave these letters into our material. So this depth will be adequate. The second section is named Tool, and in this section it contains the entire database of all the tools and knives that we have in our system. This is a very important section. In here we can change the parameters of all of our existing tools or add new tools. So there are quite a bit of information here which we need to pay attention to. So firstly, we are going to select the adequate knife for our kind of operation. Because we're going to do fine engraving of these letters, I'm going to use a knife with a small diameter and a fine tip. So in our case, we're going to use one of the V-bit knives, and we're going to select the 6mm knife at 90-degree angle. Now what does that mean, and what does it say about the knife? So in the next field we have all the parameters for this particular knife. In the right section we have a graphical representation of the knife, and the top marking is the diameter of the knife, and because this is a V-bit knife, it has a predetermined angle. So in our case, our knife has 90 degrees angle, so we will input 90 degrees in the selected field. Number of flutes refers to the number of blades that our knife has. So in our case, our knife has two blades. One is on the left side and the other one is on the right. And these blades are the ones that do the work on the piece. They are the ones that engage with the material and remove it. So we need to input the correct number of flutes or knives. Beneath it, we have the cutting parameters. These are very important. The pass depth is set up to 1.5 millimeters. I'm going to lower that to 0.5 millimeters. What does this mean? It means that for this particular knife, this one, V-bit, which is 90 degrees and 6 millimeters, each time that we're going to use this particular knife, it is going to enter the material for 0.5 millimeters. So that's the maximum depth that we have allowed this knife to progress into the material. The clearance pass step over is a parameter which is used to control how much the tool will overlap its previous pass during material removal. This setting is critical when using larger tools, especially for roughing passes, as it determines how efficiently and smoothly the tool clears away the material. So we can regulate that by adding millimeters, or we can do that with percentages. The next section, called feeds and speeds, is also very important. Some would argue the most important one. And here we determine the spindle speed, we determine the feed rate and the plunge rate of the knife. So the spindle speed depends on it's dependent from various factors, such as the type of material that we're using, the kind of knife that we're using, and also the maximum RPM of our spindle. So in our case, 5,000 revolutions should be quite enough, but I'm going to increase it just a little bit to 6,500. The feed units, this depends on your needs, but in our case we will use millimeters per minute, and this is reflected in the bottom sections, the feed rate and the plunge rate, and we can see that they have changed to millimeters per minute. So the feed rate is determined by the number of flutes that we have on our knife. For larger knives, let's say we use 3,000 to 3,500 millimeters per minute per flute. So if our knife has 2 flutes, then we add those. So we end up with 6,000 to 7,000 millimeters per minute. But because we are working with a very fine and small knife which has 6 millimeter diameter, I'm going to use a conservative number. In our case it will be 1,500 millimeters per minute. And the plunge rate, which regulates the speed or the rate at which the tool will enter the work material. So how fast or how slow the tool enters the material is determined by this number. So here in tool number we can assign this particular tool with his number if our machine supports automatic tool changers or tool management. In my case, my machine does not, so I will just leave it as number 1. After we're done with this setup, we can click the apply button and select, and we can see in our toolpaths bar that we have the V-bit knife, which is 90-degree angle and 6 millimeters diameter selected, and below that there is a section called passes, which determines in how many passes our machine will complete the job. Now, if you remember, when I set up this knife, I put a value for its pass depth to 0.5 millimeters, but our final depth is 1.5 millimeters. So the software calculates this and determines that it should finish the job in 3 passes, because this knife is only allowed to enter the material for 0.5 millimeters. It will take it 3 turns in order to achieve the final depth, which is 1.5 millimeters. But that doesn't necessarily mean that it's fixed like that. So if we click on the button called Edit Passes, we're greeted with a new window, which is called Specify Pass Depths. And in this window, we can determine each individual entry into the material, how deep it enters and how many passes should it go. Here in the first pass, we can select for a lower depth, like let's say for example 0.2 millimeters. And if we click apply, we see that the first layer is 0.2, the second pass will be 1 millimeter, and the third pass will be 1.5 millimeters, independent of how much we inputted on the knife. So we can do that, or we can clear all passes, so it can finish the job in one go. In our case, let's just add, we set 3 passes and it generates them automatically. We click OK and we can continue with the other functions. The knife and offset its pad outside from the vectors. So let's say for example we want to cut a square and we have assigned some dimensions to it, like for example 50 millimeters by 50 millimeters. If our knife was directly on the line and it started cutting, we will lose some of these dimensions because of the diameter of the knife is exactly on the line. But if we need the piece to be with its exact dimensions, we select the option outside of the vectors so that the software can take the diameter of the knife into consideration. If we need to do the opposite effect, like for example we want to remove material from this cube and we want the finished hole to be with the exact dimensions which we previously assigned, we will choose the second option, which is called inside the vectors. So in this case, the software also takes in consideration the diameter of the knife, and it offsets the path of the knife inside of the vectors. And we will use the option on the line or on the vector directly, which is used for engraving either letters or any type of vector. Our next section is do a separate last pass, and it's used to improve the edge quality of a cut during a profile toolpath. When this option is enabled, the CNC machine performs a final shallow pass around the perimeter of the shape after the initial roughing passes. And the next section, called Add Tabs to the Toolpath, it's an option which is used to keep the material in place while cutting out the shapes, especially while performing profile cuts. So tabs are they are small uncut sections of the material which connect to the part. They connect the part to the surrounding stock, preventing it from moving during machining. And these are pretty useful because without using tabs, smaller parts can move or shift when they're cut free, and they can cause damage to the part or cause damage to themselves or the tool or the machine. So it protects the tools. They ensure the tool doesn't collide with loose parts, which could cause breakage or inaccuracies. So in our case, we don't need to use these because our operation is only to engrave the surface. We will not cut through the material with these functions. So we will not use the separate last pass and add tabs to toolpath. Our next section, which is pretty important, is to add ramp effect to the toolpath. What does a ramp effect mean? Well, for different types of knives, some knives cannot enter the workpiece perpendicularly, so they need to enter at an angle. And with this function, we can determine the type of angle or the way in which the knife enters the material. So we will, for our purposes, we will use smooth or linear way. So it can be smooth, it can be in a zigzag fashion. So the knife goes zigzag until it enters the specified depth, or it can use a spiral way, in which the tool makes small spirals until it reaches the desired depth. So for our case, as I said, we will use the smooth type, which gives us a different option to determine the distance at which it enters or the angle. In our case, we will use the angle, which I will set up. It is 30 degrees, which is optimal for our purpose. So the final step which we need to do is name our project. So I'll just write test 01, and we can click on the calculate button. After this, we can see there is a graphical representation of the toolpath and the finished job. So our tool, when we determine the origin points on the machine, it will start from the bottom left corner of the workpiece. It will move to the middle of the piece where we have positioned our vectors, and it will enter the first letter, it will finish engraving it, and then it will move to the next letter, and so on. The red lines are the movement of the cutter head while it's out of the material, and the blue lines represent the tool paths when the knife is inside the material and it's removing the material itself. So after we're done, we can simulate this. We can determine the speed. I will just lower it a bit, and we can press play, and we have a graphical representation of how the machine will finish the job. After we're done with the simulation, we can close this bar, which is named Preview Toolpaths. And we notice that in the Toolpaths field, we have our recently finished toolpath named Test 01. The only remaining thing to do is to select it, and we can save this toolpath. We select the adequate post-processor, and we click on Save Toolpath. We can save it anywhere we want, and we're ready to machine it on our machine. So after we've finished with our profile toolpath function, we can continue with the other types of toolpaths, And the next thing which we're going to work with is the pocket toolpath function. So first thing that we're going to do is we're going to import a file, and we can do that by clicking on the file menu bar, which is on the top left corner, and choosing the import function, and then selecting import vectors. Or we can do the same thing by pressing the Ctrl and I letters on the keyboard. We locate our DXF file and we click open. So we can see that the software has loaded our file, but is quite bigger than our work surface is. So we can change that, and if you remember, we do that with our function called scale objects, which can be found in the transform object section. So we make sure that our entire drawing is selected, all the vectors are selected and they have the purple coloring, and we click on set object size. So now we can change the size. We make sure that our X and Y coordinates are linked, so that when we change one of these values, the other changes respectively. So we're going to change this into, let's say for example, 350 millimeters. And then we click on the apply button. We zoom in. And we can see that our drawing has manageable dimensions now. We position it where we want to on our workpiece. And we are ready to assign it some toolpath functions. We close the size changing bar and we select all of our vectors. Now we can go in the toolpath menu and choose the second option called pocket toolpath. And what is a pocket toolpath? A pocket toolpath is a function in Vectric Aspire which is designed to remove material from flat or recessed areas with a closed vector boundary, of course. This feature is commonly used to create pockets, cavities or recesses which are designed for signs, plaques or inlays. The user can specify the depth of the pocket, select the appropriate tools for this configuration, and set up cutting strategies to optimize material removal while ensuring a clean finish. The software will allow for multiple tool setups to handle roughing and finishing passes, and it can provide a precise control over tool engagement and cutting performance. So our pocket toolpath option is the second one from the toolpath operations bar, and we need to make sure that the vectors which we intend to apply this function to are already selected, and then we can click on the pocket toolpath option. So we can notice that it has a couple of similarities with the other function, such as the cutting depths, the tool selection, the ramp effect, and as well as determining the passes. So I'll begin with the setting the cutting depths. Our starting depth will again be 0, and our final depth, well, 2 millimeters should suffice. It's just as an example. So next thing which we need to do is to select our appropriate knife, and for this I will go with first our end mill. So I need to make sure that it's the correct end mill. I'm selecting our knife, and in the right section of the tool database we set up all the parameters for our knife. So I can see that the diameter is inserted correctly, which is 3 millimeters. The number of flutes is also 2, because our knife has 2 flutes. The pass depth I'm going to change to 1 millimeter, which means our knife will only enter the material in increments of 1 millimeter. And the step over is an important function here, because the step over will determine how clear and smooth our surface finish is when we use the pocket toolpad function. So you remember when we used the profile toolpad function, we also had this option to set up, but in here it plays a much greater role than it does in profiling toolpads. So it determines by what percentage of, or how much in millimeters, our toolpads will intersect with each other. So I believe that 20% should be enough for this application, and I'll leave it as it is. Our spindle speed is to maximum. We make sure that the feed units are millimeters per minute. We check the feed rate, which is 4,500. For our purposes, it should suffice. And the plunge rate is 250 millimeters per minute. I'll just increase that to 350 millimeters. We leave the tool number as it is. We hit on the apply button and we click the select button. I can see that we already had a knife selected, so I'm going to remove this one. Now we have our desired knife and we can start working on the passes. So if we click on edit passes, we can see that our knife is allowed to only enter in increments from 1 millimeter, and it will finish the job in 2 passes. I'm pretty satisfied with that, so I'll click on the OK button. Our next function which we need to assign is the way that the pocket toolpad function will be executed. So we have 2 options, which are offset and raster. So the offset function uses geometry which starts from the middle of the part. Let's say, for example, we're going to work on this final, the last shape in our row. So our pocket toolpad will start from the middle of the piece, from the middle of the vectors, and it would slowly clear out material towards the outsides. If we choose the offset option, and if we choose the raster option, it will start from the top and it will move in a zigzag fashion all while cleaning the material from the selected vectors. So which of these options should you choose? Should you go with offset or raster? Well, it mainly depends on the geometry of the vectors which you're trying to process. So what is the difference? Well, offset pocketing is when the toolpad starts at the edge of the center or of the pocket, and it spirals inwards or outwards in a series of concentric passes. The advantages for these are it's more efficient for certain shapes, especially when they're circular or rectangular pockets, as it minimizes the non-cutting tool travel. It often also leaves a cleaner edge finish because the tool maintains a consistent direction of movement. And the advantages of a raster pocketing, for example, when you choose raster pocketing, the tool moves back and forth in straight parallel lines, like a printer or a lawnmower mowing in rows. The advantages are that it produces a more consistent surface finish, especially on flat areas, and it's ideal for larger pocket areas or areas where smooth finish is prioritized. So the user can also control the raster angle to align with the grain of the material or optimize its cutting directions. But the raster pocketing also they both have disadvantages. For the raster, it tends to leave tool marks at the edges where the tool changes direction, for example, and it's less efficient offsetting method for certain shapes, while the offset pocketing may produce uneven surface finishes for large flat areas due to the overlapping spiral pattern of the way it works. And for irregularly shaped pockets, it may be less efficient than rastering. So for our purpose, I'm going to choose the raster effect because we have a lot of geometric forms, and they're all different in size and different in orientation. So that will have an effect on our pocketing method, should I say. So we leave the raster angle as it is. We add our plunge moves, which should be at 20 millimeters. We do not set any pocket allowance, and the only thing that's remaining is to name our file. I'll just write in test02, and we can click on calculate. I see. So it turns out that our drawing is unsuitable. What does that mean? Some of these vectors are not completely closed, and we must fix that before we can apply this toolpath. Why does this matter? I'm going to click on OK, and we can see the software informs us that no toolpath has been generated because the vectors are not closed. What does that mean? That the vector is open somewhere in this line. I'm not sure where it is, but somewhere the vectors are not completely closed. So if I zoom in, we can see that here the vectors are indeed closed, but somewhere along the line they are opened, and the software does not see this geometry as a closed system. So it thinks that it should step out of it and move outside of the working area. So we must fix that, and the way we do it is we select all the vectors. We go to Edit from our menu bar, and we choose the Join Vectors option. It will give us the total number of open vectors from our selection, which it says is 55, and 0 closed. So after we close them, we will have 37 joint vectors, and we set up the tolerance for how much of a gap should the software act in and close these vectors automatically. I set it to 2.2 millimeters, which is a very high tolerance, but I want to make sure that it completely joins all the vectors. So I click on the join button and close, and now our vectors should be suitable for the pocket toolpathing option. We return to our toolpath sidebar, we go down to calculate, and we click on calculate. And now we can see that our toolpaths have been generated on the workpiece. So our knife will start moving from our 0 position, will get near the closest closed vector, it will enter the workpiece and start removing material in a zigzag motion, going left to right, left to right, left to right, just like I said, like a printer or a lawnmower. And after it's finished with this selection, it will get out of it and move to the next one. We can also see a preview of the simulation. We can open the toolpath bar, and we have the preview toolpath section, and if we click on run, we can see how the software will fix this. So Vectric Aspire is a very powerful software, and it's used for designing and creating 2D and 3D models for CNC machining. It's very popular in woodworking, in sign making, and detailed 3D carving projects. It's a very good software, it's a user-friendly, it's great for both beginners and experienced makers. Thank you for watching, and I'll see you again. Bye.